This video, we're going to find the variance and standard deviation of a population or sample. So first, let's ask, why is the standard deviation used more frequently than the variance? It's because the units of variance are squared, so the units are meaningless to us. We want to know more what the size of a standard deviation is. It's a measuring stick that we can use to measure to the right and to the left. The numbers of regular season wins for 10 football teams are given in a given season are given below. Determine the range, mean, variance, and standard deviation of the population data set. So let's go ahead and go into stat, edit. Again, you can make these same calculations in Excel. I'm just going to show you how to do them in the calculator right now. You put your data list in Excel and you put in the appropriate commands, you can find the range, the mean, variance, and so on. So this is a population. So we are going to take the number of things here as capital N, and we're going to find the sum of all those things and divide by capital N. I'm just going to let my calculator do that for me. Stat calc, one variable statistics, L1. There's no difference here for what the mean would be. We're just going to call it mu instead of x bar. It's going to be 7.9. The range we're going to get from max minus min. We'll have to do that by hand. So 15 minus 2 is going to be 13. Population variance is going to be this number for the standard deviation here squared. So I'm going to make my calculator do that in a second. The population standard deviation to the nearest tenth is 4.4. And I'm going to go into VARs, statistics, and we want sigma of x here, and I want to square it to get the variance. And I get round the answer to the nearest tenth is going to be 19.3. We can also come in here to list, operations. Let's see, there it is. Under math, there's standard deviation and variance. If I want the variance of what's in L1, that's the sample variance. That's why I didn't use that, because population variance is going to be sigma. This gives me s squared. It's a little different, so I'd have to change my calculation a little bit there. But I can definitely go in and find my variables, my statistics variables, and go in there and get their sigma. There's your min and your max. We'll use some of these other things later. You can get all those variables that we need. All right, let's go in here and let's put a new list in. Come up here, clear, enter. We got 12, 18, 23, 13, 19, 17, 22, 18, 13, and 19. And let's run our one variable statistics on this. The range is going to be max minus min. 23 minus 12 is 11. The mean is 17.4. The variance is, for a sample, So we'll figure out variance in a minute, but our standard deviation, we're going to use the SX here since it's for a sample, and that's going to give us 3.7. Now I can come out here and use this variance command like that to get the variance, and it's going to be 14.0. Now let's compare these three data sets on the right where we use these dot plots here. Which one has the greatest standard deviation? That's going to be 2 because it has the most data that is far away from the mean. So these are 1 and 3 are closer compacted to the mean there. Which data set has the least sample standard deviation? That would be 3 because it has more data entries that are close to the mean. And how are the data sets the same and how are they different? The three data sets have the same mean, median, and mode, but have different standard deviations. So if we would look at 8 is the mean, median, and standard, mean, median, and mode for all three data sets. They're all basically normally distributed. 2 is the most normally distributed out of all of them, but they've got that property of having the same mean, median, and mode, being that all those averages being the same, but they have different standard deviations. The data is more spread out in some than it is in others. All right, that's it for this video. We'll come back next time and keep talking about 2.4. See you for the next video.